All right, so in our last video, we looked at the ideal gas law, and we did our notes for the ideal gas law. Now I'm going to run through our first set of practice problems. And so we've been working on M100, maternity leave, page 100, and now we're going to be on maternity leave, page 101. I just realized, since this was my first video that I made, that I had you put your notes on the even numbered page, and so we'll fix that in the coming pages, but it's okay. So either your notes should either be on page 100 or page 101 if you caught my mistake. All right, so we're going to do the first set of practice problems, and so they will either be on page 100 or 101, depending on which one you have left to fill in. And so we are going to remind ourselves first, before we do any of this, about our gas law equation. And so this is either page M100 or page M101, depending on what you, what you have missing. Okay. So we know that our gas law equation is PV equals nRT, and we know that our R is 0.0821 L ATM MOL K. And so we're just going to remind ourselves of that as we're solving these problems. So this one says, at what temperature will 0.01 moles of argon gas have a volume of 275 milliliters at 100 kPa? And so this one automatically, we know we're going to have quite a few things to do because our units don't match what they need to be: liters, ATMs, moles, and Kelvin. Okay, so we know that we're looking for temperature in this one. So we're going to try to find temperature, but we're going to go through our list. So if given, we have PV, nRT. And we may have to do some work for some of these in order to get them in the right unit. So at what temperature? So we are going to be looking for temperature. That is going to be our X. Well, 0.01 moles. So that's going to be our N, 0.011 moles of gas have a volume of 275. But we know that this is in milliliters, and we can't use milliliters. So I'm going to have to take 275 milliliters, divide it by 1,000, and I get 0.275, should be a 5, 0.275 liters. And so that's an important conversion that we have to make because our volume has to be in liters. And then our pressure. Our pressure is currently 100 kPa. Well, I need it to be in ATMs. So I'm going to have to take 100 kPa and remind myself that 101.3 kPa equals 1 ATM. So if I take 100 divided by 101.3 kPa, I get 0.9, I get 3 sig figs there, so 0.9872, actually it's 4 sig figs, 0.9872 ATMs for my pressure. Okay, and that's just because I was in kPa, so I had to take that and say 101.3 kPa is equal to 1 ATM. And so that's what gave me the 0.9872 ATMs. Okay, so I am, and then my R is going to be 0.0821 L ATM over MOL K. Okay, so I have all of that information. My gas law is PV equals nRT, and the formula that I'm going to use, since I'm looking for T, is in order to get T by itself, I need to move N and R over to the other side. So my formula is going to be PV over NR equals T. And that'll give me my temperature in Kelvin. Okay, so for my work, I'm just going to plug in my information. So I know that it's PV over N, well, I'm just going to put RN, but over N and R equals temperature. So my pressure is 0.9872 ATMs times my volume of 0.275 liters. And I'm going to divide that by N, which was 0.01, 0.01. Make sure I fix that over here as well, 0.01. 0.01 moles times my R, which was 0.0821 L ATM MOL K. All right, so my ATMs can cancel, my moles can cancel, and my liters can cancel, leaving me with K. And so I just need to plug this into the calculator. I'm going to make sure I get the numbers right since I messed it up over here. So 0.9872, that's a 9, 0.9872 times 0.275 divided by, put the denominator in parentheses, 0.0100 times 0.0821, close the parentheses, and I get, going off of 3 sig figs, 331 equals 331 Kelvin as my answer for that. Okay, so let's look at our next one. What is the volume occupied by 36 grams of water vapor at 125 degrees Celsius and 102 kPa? So again, I'm going to go through my list. P equals, V equals, N equals, R equals, and T equals. And I'm going to have to deal with the units of each of these. So what is the volume? I am looking for volume. So that's going to be my X. My pressure is 102 kPa. Well, I know that I can't have it in kPa, so I'm going to go ahead and divide that by 101.3 for the 1 ATM. And so when I take 102 divided by 101.3, I'm going to get I get 3 sig figs, so 1.01 ATMs, and so that's where this came from. Right, 102 kPa divided by 101.3 gave me 1.01 ATMs. My number of moles, well, currently I have grams. It's grams of water vapor, so I'm going to have to do another conversion. I know that if I take 36 grams of H2O and I divide it by its mass on the periodic table, so H times 2 plus O, I get 18.015 grams in a mole. So if I divide that, 36 divided by 18.015, I'm going to get 1.998, and I get 3 sig figs, so that's basically 2.00 moles. Okay, and that's just because I took the mass of water from the periodic table, gave me 2 moles. My constant is always the same, 0.0821 latum molk, and then finally my temperature. So I have 125 degrees Celsius, but I know that I have to add 273 to that because it must be in Kelvin. So 125 plus 273 gives me 398 Kelvin. All right, so my gas law is PV equals nRT, but I am solving for the volume. So I'm going to have to divide both sides by P, meaning that volume equals N times R times T divided by P. So now for my work, I'm just going to plug that in. V equals N times R times T divided by P. So my N is 2.00 moles times my constant, 0.0821 latum molk, times my temperature, which was 398 Kelvin, divided by my pressure, which was 1.01 ATMs. I can go in and see that my moles cancel, my ATMs cancel, and my Kelvin cancels, leaving me with liters, which is what I wanted. So I'm just going to plug all of that into the calculator. 2.00 times 0.0821 times 398 divided by 1.01, and I get 64.7 liters, and we're going to go with 3 sig figs. Okay, all right, third problem on the page, 3 to go. What mass of carbon dioxide will occupy 5.5 liters at 5 degrees Celsius and 0.75 ATMs? So make my list. P equals V equals N R T. My pressure is in the correct unit, so I don't have to convert this time. My volume is 5.5 liters. My N is my number of moles. I don't see anything about the number of moles right now. My R is always going to be 0.0821 latum molk. And then my temperature is 5 degrees Celsius, but I'm going to add 273 to that, and so I get 278 Kelvin. All right, so I must be looking for N, but I have to remember that N is in moles, and they're looking for mass, so I'm going to have to do a conversion at the end between moles and mass. My gas law is PV equals nRT, and I am solving for N. So I'm going to have to divide both sides by RT. And so I will get, let's use this color, N equals PV over RT. Okay, so let's put that into use. N equals PV over RT. So my pressure is 0.74 ATMs times a volume of 5.5 liters times a temperature of 278 Kelvin divided by R, which is 0.0821 latam molk, and by, oh, I messed this up completely. Okay, so I got my pressure and my volume. This temperature should not be there. It should be on the bottom. 278 Kelvin. Okay, so let's talk about that because I was just doing P times V times T there. So my pressure was 0.74 ATMs. My volume is 5.5 liters. Temperature is not in the numerator there. My constant is 0.0821 LATM over MOLK. And then my temperature should be in the denominator, 273 Kelvin. So we're just going to ignore that mess up. All right, so I just need to plug that into the calculator. So I'm going to take 0.74 times 5.5. Divide that by putting the denominator in parentheses, 0.0821 times 278, hitting equals, and I get 0.178. Let me look at my units here. The L's are gone, the ATMs are gone, the K's are gone, so that's moles. Okay, and so let's just double check that because that looks like a really small number, and I just want to make sure I entered it correctly. 0.74 times 5.5. divided by 0.0821 times 278. And so, yep, I got the same thing twice. 0.178 moles. Okay, but this is moles, and my question asked for mass. So it is moles of carbon dioxide. I need to do a moles to mass conversion. So 1 mole of CO2 is going to equal its grams on the periodic table. So I need to look on the periodic table and find the mass of carbon and the mass of oxygen times 2. Well, the mass of carbon is 12.01 plus, I have to take oxygen times 2. So that's 15.99 times 2, and that's going to give me 43.99. So that's what I'm going to plug in here for the mass of carbon is 43.43.99. And that was carbon plus 2 oxygens. So if I take 43.99 times 0.178, I'm going to get an answer of 7.83 grams of CO2. And so that is going to be my final answer here, 7.83 grams of CO2. Okay, so that's our first page of this worksheet. We have 2 more problems. This was just using the gas law. Now we're going to use the gas law and stoichiometry. So let me switch pages real quick. Make sure that I get everything lined up so you can see the problems. Okay, so let's look at problem number 4. Problem number 4 says how many grams of AlCl3 must decompose in order to produce 3.10 dm cubed of Cl2 at 50 degrees Celsius and 98.4 kPa. Okay, so on your, this is a different copy. On your copy, it says we have liters here. Okay, so on your copy, instead of dm cubed, it says liters. And so I want to make sure that we change that because I didn't realize it when I made the video. All right, how many grams of AlCl3 must decompose in order to produce 3.10 liters of Cl2 at 50 degrees Celsius and 98.4 kPa? Okay, so we are looking for grams of AlCl3. We are starting with liters in our problem, and anytime I start with liters, I have to check my situation. I am not at STP, and so I can remember from my notes earlier, if I look at that notes page, I can see that if I am starting with a non-STP liter, I'm going to have to use the ideal gas law first to convert it to moles, then do stoichiometry. So I need to use the ideal gas law first to get my answer in moles, then plug the moles into my stoichiometry analysis. Okay, so I'm going to deal with this first. So I have P equals, V equals, N equals, R equals, T equals. So the pressure is 98.4 kPa. Well, I've got to deal with that because that's not in the right unit. So 98.4 kPa. I know 101.3 kPa equals 1 atm. So 98.4 divided by 101.3 gives me 0.971. And so that's what I'm going to use for my pressure, 0.971 atms. My volume is 310 liters. I'm going to be looking for my moles because that's what I need to convert to in order to put it into stoichiometry. My R is 0.0821 L atm MOLK, and my temperature is 50 degrees Celsius, but I know I do 50 degrees Celsius plus 273, and so my brain is done today. 50 degrees Celsius plus 273, and so I get 323. 323 Kelvin. Okay, so I need to plug that in, and I'm going to be solving for N. So if I have PV equals nRT, and I'm solving for N, I need to move R and T over so that I have N equals P over V times RT. Okay, so let's plug all of that in. N equals P pressure, 0.971 atms times 3 liters divided by R, which is 0.0821 L atm MOLK, and my temperature of 323 Kelvin. I go in and look at my units, atms, liters, and Kelvin cancel, leaving me with moles, which is what I wanted. So I have 0.971 times 3.10 equals, divided by, putting the denominator in parentheses, 0.0821 times 323. Close that out, and I get 0.114 moles of Cl2. Okay, because that's what I was dealing with. I haven't done any conversion between compounds yet, so I'm in Cl2. I need to get to grams of AlCl3. Well, luckily for me, they have already balanced my equation. So I just need to take this value, plug it into the stoichiometry. So I have 0.114 moles of Cl2. I'm already in moles, so I go straight to the mole-to-mole conversion. Moles of Cl2 come down, and I'm trying to get to AlCl3. So moles of AlCl3 go up. Okay, so it looks like for every 3 moles of Cl2, 2 moles of AlCl3 are needed. So that gives me the moles. I need to get to grams. So 1 mole of AlCl3 equals grams of AlCl3 from the periodic table. So I'm going to pull out my periodic table. I'm going to find aluminum, and I'm going to find chlorine. So chlorine is 35.45 times 3, and then add to that aluminum, which was 26.982, and so I get 133.33. So that's what I'm going to use for the mass, 133.33. Okay, and so I know that my moles cancel, leaving me with grams of AlCl3. So I just need to plug that in. So 0.114 times 2 times 133.33 divided by 3 times 1 is just 3. And so I get 10.1, because I'm only using 3 sig figs, 10.1 grams of AlCl3. Okay, and so remember, this was a stoichiometry problem, but we were dealing with liters, and those liters were not at STP, so I could not use the 1 mole, or the 1 mole equals 22.4 liters. I couldn't use that. I had to use the ideal gas law first. Okay, question 5, last question. What volume of nitrogen can be produced by the decomposition of 50 grams of NH4NO2 at 25 degrees Celsius and 1.2 atms? automatically know that this is not at STP because that's not 0 degrees Celsius and that's not 1 ATM. So I'm going to have to do some math. I am ending with volume of nitrogen. So that means that I'm going to have to, if I look back at my notes, if I'm ending with a non-STP volume in liters, I'm going to use the stoichiometry to get to the mole first, and then I'll use the ideal gas law. So I get to actually do stoichiometry first and flip my equations over. Okay, so I know that I have 50 grams of NH4NO2. Okay? And I'm going to do my stoichiometry first. So I'm going to take my grams of NH4NO2, and I'm going to go to moles of NH4NO2. All right, and so I know that 1 mole is going to equal the mass of the periodic table of N, 4 H's, an N, and 2 O's. Okay, so I'm going to say that I need to take oxygen, which is 15.99, times 2, plus nitrogen, which is 14.007 times 2. Notice that I'm putting all of those in parentheses. Plus hydrogen, 1.008 times 4. Now, I may have just lost you for a second, and that's okay. I'm going to plug it in and make sure that I've got this right. 64.03. I said nitrogen times 2 because there were 2 nitrogens, and so I just added those together. So I did 14.007 plus another nitrogen, 14.007, plus 15.99 for oxygen, plus 15.99 for oxygen, plus 1.008 times 4 for hydrogen. I get 64.03. Okay, so we did that correctly. So that takes us to grams to moles, but I'm going to actually do my conversion all the way through. So I'm now going to go moles of NH4NO2 to moles of the thing I want, which is nitrogen, N2. And so I can see that this looks balanced, 2 and 2, 4 and 4, 2 and 2. Okay, so these are ones. 1 mole of NH4NO2 provides 1 mole of N2. So I'm going to do my calculation here. And so I'm going to take 50 times 1 divided by 64.03. So 50 times 1 divided by 64.03. And I get 0.781 moles of N2. Okay, but this is moles of N2. They wanted it to be volume of N2. So now I'm going to take the moles and I'm going to plug it into my PV equals nRT. PV nRT, and I'll be able to get my answer. So my pressure in my problem is 1.02 ATMs. My volume is what I just found, 0.87. I'm sorry, it's not what I just found. Volume is what I'm looking for. My number of moles is what I just found, 0.871 moles of N2. My constant is always 0.821 latum mole, and my temperature is 25 plus 273, so 298 Kelvin. Okay, so I'm looking for volume. So when I write my equation, PV equals nRT, and I'm solving for volume, I'm going to have to divide both sides by pressure. Okay, so I'm just going to take N times R times T divided by P. So my number of moles was 0.781 moles times my R, 0.821 latum mole, times my temperature, which was 298 K. Divide all of that by P, pressure, 1.20 ATMs. And when I do that, my moles cancel, my ATMs, and my Kelvin, leaving me with liters. So I just need to plug that into the calculator. 0.781 times there should be a 0 there, 0.0821 times 0.0821 times 298 divided by 1.20, and the answer that I get is 15.9 and that would be liters as my final answer. Okay, so if we compare these two problems, I did them in different orders. This one, I was starting with liters, so I had to use the ideal gas law first to get to moles, and then plug it in from moles to get to the conversion that I wanted. My second problem, I'm ending in a volume or ending in liters. So I do my stoichiometry first and change my compound to moles, and then I plug that into PV equals nRT in order to get me my final answer. Okay, so hopefully this helped you with your first homework, which should be done on either page, Maternity 100 or Maternity 101, depending on what side you worked your notes on. Okay.